Alright, go ahead and get out your journals and turn to your unit title page. Today's lesson is 1.4, Function Notation. Notice the word fun in function. Just kidding. Okay, turn to your notes page and we'll get started. Alright, so let's start at the top and define function notation. Basically, function notation is just a way a function is written. Most of the time you're going to see it as like f of x equals, and then it's going to be the function, okay? Remember that x is the input, and then f of x is the same thing as y. So over here I have a picture of a function machine. So you're going to input the x into the equation. So maybe the equation's like 3x plus 2. And then it's going to spit out an answer, which is y or f of x. Remember, that's the same thing. So let's come over here. If I input a smiley face into this equation, I'm inputting it in place of x. So this would be 3 smiley face plus 2. Okay, or I could input a star. So it would be 3 star plus 2. Or if I want to input a number, I could have 3, I would input a 4 in place of x plus 2. Well, since we actually have a number, we could evaluate this. So 3 times 4 is 12, and then 12 plus 2 would be 14. So basically, anytime you have function notation, it's going to involve inputting something into the x, or whatever your variable is, your input, and then it's going to spit out an output, which is your y, or your f of x. So let's look at some examples down here. Use the following function rule to evaluate f of 3. So 3 is going to be what I'm putting in place of x. So I'm going to replace the x with the 3. So I could write this as f of 3 equals 7 plus 5 times 3. I'm putting 3 in place of x. And then you just need to evaluate it. So f of 3 would equal 5 times 3 is 15, and then 15 plus 7 would be 22. So basically what this means is if you were going to graph this, this would be like an ordered pair. 3 would be your x, and then 22 would be your y. Okay, 3 is the input, and then 22 would be the output. All right, let's move over here to number 2. Now we're going to use this function rule to evaluate g of negative 2. So I'm going to put negative 2 in place of this variable, which is now an n. So everywhere you see an n, you're replacing it with a negative 2. You're inputting it into that equation. Remember, you always want to use parentheses whenever you're inputting numbers into an equation, especially when you square them. So make a side note, always use parentheses. Because whenever I go to evaluate this, if I forgot to put negative 2 in parentheses whenever I square it on my calculator, it's going to do 2 squared first, which is 4, and then make it negative. But we don't want that. We want to square the entire negative 2. So negative 2 squared would be negative 2 times negative 2, which is positive 4. And then we would have minus 3 times negative 2. So that would give me a positive 6 and then a positive 5. So I would be left with 4 plus 6 plus 5, which would be 15. So g of negative 2 would equal 15. And just like earlier, we could actually write this as an ordered pair. negative 2 is your x, and 15 would be your y. Moving on to number 3. This time we're going to be inputting this entire expression in place of the u because u is the input. So if I wanted to find h of negative s minus 3, that would be 8 times negative s minus 3, because I'm inputting that whole expression in place of the u, since u is the input. Now we just need to simplify it. So this would equal 8 times negative s would be negative 8s, and then 8 times negative 3 would be negative 24. So this one we actually can't evaluate to get a value because we don't know what s is. We were just simplifying this expression, and so h of s minus 3, or negative s minus 3, would equal negative 8s minus 24. All right, last one. So we are inputting 3j plus 3 in place of a. So everywhere you see an a, we're going to be inputting 3j plus 3 into that. Okay, so I need to square that whole expression. So 3j plus 3 squared, and then plus 3 times 3j plus 3. Okay, let's go ahead and simplify it. So I have 3j plus 3 squared. All right, we're going to do a little review of multiplying binomials. See, I told you this would be fun. Remember, 3j plus 3 squared is really the same thing as 3j plus 3 times 3j plus 3. So you could either do the box method or you could distribute it out, okay? If you do the distributive, you're going to multiply your first and last, or first, outers, inners, and last. Or you could draw a box. So this would be 3j plus 3, 3j plus 3, and then just multiply. So 3j times 3j would be 9j squared. 3j times 3 is 9j. 3 times 3j would be 9j. And then 3 times 3 is 9. So whichever method you got, you should have ended up with, whenever we combine our like terms, 9j squared plus 18j plus 9. So this whole expression is what we get whenever we square 3j plus 3. So I'm going to write that back up here, 9j squared plus 18j plus 9. And then we need to add on the rest of this expression. So I need to distribute out this 3. So 3 times 3j would be 9j, and then 3 times 3 is 9. Okay, I'm going to erase this work down here just so I'll have more room to work with. So now we just need to simplify this. So combine your like terms. I've got 9j squared. Then I'm going to combine my j's. So I have 18j and 9j. So if I add those together, 18 plus 9 is 27j. And then combine your 9 and your 9 to get 18. Ooh, that one was a little bit harder. So you should end up with 9j squared plus 27j plus 18. All right, y'all are going to do an IXL over this part today. And then we're about to do the second page of the notes, so don't go ahead and put it up yet. But tomorrow you're going to do an IXL over the second page of the notes. But let's go ahead and flip over there and go ahead and do those. So we'll have those out of the way. On this example, we're going to be using graphs instead of equations, which I think y'all will like better. So we're going to use the graph of f to find f of 4. So remember, whatever is in the parentheses is your input or your x value. So we would input a 4 into the equation, and that would give us this graph, and then it would spit out a y value. So on this line, we need to go to when my x equals 4, which would be right here. So whenever x equals 4, what does the y value equal? And that would be at 3. So this coordinate is 4, 3. So my y would equal, or my f of x would equal 3. Remember that y and f of x are the exact same. All right, number 2. So this time we're going backwards. We don't know what the input is. See, there's an x there. We don't know it. Over here on number 1, we could tell that the input was 4. But on number 2, the input is just x. What we do know, though, is that the output is 9. So this is going to be your y value. So we're going backwards. Now we're going to start on the y-axis and figure out, well, when my y is 9, what are my x values? And since this is a parabola, we actually have 2 y values at 9. So the first one, if I come down here, I can see that my x would be at 1. So this is at 1, 9. And then my other coordinate would be at 9, 9. So that means x would have to equal 1 and 9. Okay, last one. Use this graph of f to find f of 8. So we know that 8 is the input, or the x. So let's look at the graph whenever x equals 8. So what's going on here? I've got something that is a discontinuous graph, and it looks like we've got a solid value and then an open value. So since this open circle is actually not a point on 8, we have to go with the one above it, which is at 3. So this coordinate would be at 8, 3. So if 8 is the x, that means 3 is the y. So f of x would have to equal 3. All right, that's it for your notes. Hope you guys have a great day. Let me know if you have any questions.